Welcome back. In this last lesson for Unit 5, we're going to be looking at the final range of solutions which are used to help keep data safe from security threats. We're going to be looking at firewalls, proxy servers, and SSL security protocols, and even TLS, which is the modern form of SSL. Both of these protocols are used for encryption, which is used to keep data safe during data transmission. Let's start by looking at firewalls. These are the most common form of defense nowadays against hacking, malware, phishing and pharming, and these can be either hardware or software. A software firewall is normally controlled by your operating system, and the hardware is a physical device that you plug into your network and that sits between the external network, perhaps the internet, and your network. The purpose of a firewall is to filter information which is coming into the computer and going out of the computer. This allows the user to decide whether or not to allow the communication with an external source, and it also warns the user when an internal application is trying to communicate with someone outside without permission as well. If an external user is trying to access the computer, there's a warning given for that as well. Firewalls are the primary defense of any computer system against hacking and malware. Now, the main tasks carried out by a firewall include examining the traffic between the user's computer and the public network, for example, the internet. So it checks what's going on, what's coming in, what's going out. And it does that by comparing it against a set of criteria that has to be preset by the user or the network administrator. It then blocks this traffic and gives the user a warning that there may be a security issue if the data fails that particular criteria. It logs all incoming and outgoing traffic to allow later interrogation by the user. So you have audit logs and you can look through them. It allows you to set the criteria to prevent access to undesirable websites as well. So you can block those websites, and you can do the same thing because it keeps a list of undesirable IP addresses as well. So not only are you looking at a particular website, you can block an entire IP address range. And this helps in preventing viruses or hackers from entering the user's computer or the network itself. It also alerts users if software on the system is trying to access an external data source. For example, you might have a keylogger, or perhaps your operating system is trying to do an automatic software update and you have not pre-specified that. The user is given the option that, okay, should you allow this or should you not allow this? It also allows the closing of ports on a network. And what's a port? A port is generally an entry point into the network. Applications will open ports to allow communication with external web servers. And depending on how they're coded, some apps, when they're closed, don't actually close ports. Hackers may want to find these open ports, so a firewall can be used to close any open ports that an application might leave open to prevent all of this. Now, firewall can't prevent all potential harmful traffic because they're just a device or a piece of software. It cannot, for example, prevent individuals on internal networks using their own hardware devices to bypass whatever the firewall does. For example, using a smartphone or a modem or creating a hotspot, you can bypass the firewall pretty much anywhere. Of course, there's employee misconduct or carelessness that cannot be controlled by firewalls. For example, you can share passwords with somebody else and allow other people to get into your network. Users on standalone computers can choose to disable the firewall as well, leaving their computer open to harmful traffic from the internet. All of these issues require management control or personal control on a single computer. And to enable that, good training procedures need to be put in place. If that's there, then the firewall can get on with its own job pretty much effectively. So please make sure that you never use the words firewall can prevent hacking. It cannot. It can simply reduce the risk of hacking and all of these other threats like malware, viruses, spyware, and so on. The next device we're going to be looking at is the proxy server. Proxy server also acts as an intermediate between the user and a web server, and they help speed up web access, but they can also act as a firewall. They generally help with DDoS type attacks. Now, if you look at the diagram, you'll probably see that the user's computer has a web browser and that sends a request normally to a web server. The proxy server is sitting in the middle between the web server and the user's computer, and that takes this particular request. It then examines that request, and if it's a genuine request, forwards that request to the web server. The web server sends back whatever the response is, and that then is forwarded by the proxy server back to the user's computer. Because it can do that and it's sitting in the middle, you can even cache all the information that's stored on the web server onto the proxy server itself. So it actually becomes a pseudo second server, a proxy of the original server. So what are the common features of a proxy server? Well, they allow internet traffic to be filtered. It's possible to block access to a website if necessary. It keeps the user's IP address secret, which improves security. So the web server's address is only known to the proxy server, and the whole world just knows the proxy server's address. And similarly, if you're putting up a proxy server on your network, your IP address, your real IP address, is kept secret by the proxy server. So the whole world just sees your proxy server's IP address. If the traffic is valid that's coming to the proxy server, access to the server or the computer is allowed. And if it's invalid, obviously it's blocked. It is possible to also block requests from certain IP addresses. So if you know that people are trying to spam you or attack you, you can block that set of IP addresses. It prevents direct access to the web server by sitting between the user and the web server. And of course, if an attack is launched, it hits the proxy server. And this helps prevent hacking and DDoS because not all repeated requests will reach the main server. And this makes it more difficult for the attacker to flood the server. It can also be used to direct invalid traffic away from the web server, which gives additional protection. And by using a feature known as a cache, it is possible to speed up access to information and data from a website when the website is first visited. You can cache all of this, and then instead of going back to the web server, you just go to the cache. Most browsers also use a cache system to store commonly accessed websites to speed things up. However, it's not really a proxy server, it's just a cache there. A proxy server will have its own cache. And that helps speed up access to websites because you're not going to the main source. You're just going to a repository of existing information, which gives much faster access. The final security solution we're going to be looking at is encryption based, and the technology we need to know about is Secure Sockets Layer, or SSL. Now, this is a protocol, and a protocol is a set of rules used by computers to communicate with each other across a network. And this particular set of rules or protocol allows data to be sent and received securely over the internet by using encryption. So when a user logs onto a website, SSL will encrypt the data so only the user's computer and the web server are able to make sense of what is being transmitted. A user will know if SSL is being applied when they see the HTTPS or the small padlock in the status bar, or often the address bar at the top of the screen. The address window in the browser when HTTPS protocol is being applied rather than just HTTP protocol is quite different. So if you look on screen, you'll probably see a padlock, normally a green or gray padlock, which will be right next to the web address's name. Whereas if you're using HTTP, that will not exist. That's your first visual indication that you're using a secure website. So how does the process work? The user's browser sends a message so that it can connect with the required website, which is secured by using SSL. The browser then requests the web server to identify itself because it needs to check its identity. The web server responds by sending a copy of its SSL certificate to the user's browser. The browser can authenticate this certificate because it will check against a trusted store where it says, okay, all of these certificates from these sources are genuine. And if it's valid, it then sends a message back to the web server so communication can begin. And once this message is received, the web server acknowledges that, okay, everything is fine, I trust you, you trust me, and then SSL encrypted two-way data transfer begins. And if a third party tries to intercept it, yes, they can get the data, but they won't understand what it is because they don't have the key. So what's this SSL certificate? Well, it's a form of digital certificate which is used to authenticate a website. This means any communication or data exchange between the browser and the website is secure, provided the certificate can be authenticated. So it must come from a trusted source. Now, examples of where SSL could be used include online banking for financial transactions, online shopping or e-commerce, when sending software out to a restricted list of users, sending and receiving emails, cloud storage facilities, intranets and extranets, as well as the internet as a whole, voice over IP, when carrying out video chatting and audio chatting over the internet, perhaps when you're using instant messaging as well. And of course, social networking sites use this all the time. Even gaming uses encryption to make sure that the traffic between your game console and the server is encrypted and secure. So what's this HTTPS and TLS all about? Well, standard HTTP protocol is HTTP. So when we add a security layer on top of that, it becomes HTTPS. Normally, SSL or TLS, transport layer security, is used. And TLS is just a newer version of SSL technology. Instead of using a single layer, it uses two layers, and each layer can be upgraded independently of the other. So the first layer is for establishing identity, authentication. Are we who we say we are? And the other is for data transmission. So if in the future you got a newer protocol for data transmission, you can upgrade that independently of your authentication protocol. And if your authentication protocol needs to be upgraded, you can do that independently of your data transfer protocol. Normally, if you click the small padlock before the start of a URL in the address bar, you can view the digital certificate of a website. So in this case, I've got chat.openai.com, and if I click that particular padlock in Safari, I can see the details of the security certificate, and you can see on screen that SSL is probably the main one it's using as well. And you can delve a bit more deeper on who issued it, where it came from, what's the validity date, all sorts of information is present here. Okay, that's all you need to know for now. Of course, you can delve a lot more deeper into all of these technologies, and you will do that at AS and A level later on. For now, you should be able to answer the following questions. How can a firewall protect a system? Explain the use of a proxy server. What does SSL stand for, and how does it help with security? How does the browser initiate an SSL or TLS-based transmission? That entire process from the browser to the web server, exchanging of certificates and validation, all of that needs to be mentioned here. What is a digital certificate and what are the two common uses of it? Now, if you can answer the following questions, brilliant. If you're not, if you can't, then perhaps rewind the video and have a look through it again. Otherwise, post your question in the comments and I'll get back to you. And with this, Unit 5 is at an end. That's all for now, and I'll see you in the next one.